But this is what I wanted to look at here, right? So suppose you're rolling two six-sided dice and adding, right? And you do this when you're playing games all the time, right? And so like, what is the probability of rolling a 2 or a 3 or a 4, et cetera, right? So, here there's sort of different ways. So here's one of those cases where there's kind of two different things you can do. So suppose I said, what is the probability of rolling a prime number, right? When you roll here, okay? So one thing you could do is you could come in here and like, here's your total space of outcomes, right? Because you could roll, let's call this the first die and this the second die, right? So when you roll, you could get a 1 and a 1, or you could get a 1 and a 2, or a 1 and a 3, or a 1 and a 4, right? So all those outcomes are in this table, right? Now here I've already added things together, right? The actual outcomes would be 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6, right? And then here would be 2, 1, 2, 2, right, et cetera. Now here I've added things already, right? Does that make sense?
Yeah.
Okay. And so there's 6 outcomes for this and 6 outcomes for that. And when I have a process that gives me, 6 outcomes and 6 outcomes, and all together I get 36 possible outcomes, right? So one way of finding like the probability of here, let me unlock this. I got to turn off this too. Okay. So here I'm going to say, let's find the probability of rolling of like, and the way we write this, X will be the outcome we're going to get. So like if I rolled a 1 and a 3, X here would be 4, right? So this is the random variable. So it means the outcome from our process, right? So let's say, what is the probability that X is prime? Okay. So there's sort of a reasonable, kind of fun question to ask. Okay. And here we're going to have two ways that we can kind of think about this. So one way is going to be this, right? One way we can say, let's count the number of, let's have an event E, right? And when I put number, I mean the number of things in the event, right? And let's have over the number of, and I'll put O, right? Where E equals the event that let's see, that the sum is prime. Okay, and O equals all possible outcomes. You can tell my typing is great. Okay, so there we go. And let me stretch this out even more so we can see. Okay, so this is one way of computing probability, right? So one way of computing probability is to look at, count everything in the event, right? And divide by all the possible outcomes, right? So this is one way of approaching your probability questions, right? And so that's like what we did in topic 5DQ2, right? There was always like, compute all of the possible outcomes you have, right? And then the other part of the question, part of the rest of the question was, what are the number of winning outcomes, right? And then the way you got your probability was to divide, right? Does that ring a bell?
Yeah.
Okay. But that's not the only way. I mean, this is what I'm saying. There's more than one way of doing things. This is part of what I'm trying to get at here. So let's do it this way. So the primes are things that are only divisible by 1 in itself, right? So 2 is a prime, and 2 is the only even prime, right? So I'm just gonna mark these in blue, right? So 3 is prime, right? 5 is prime. And I don't think Excel has an is prime function, so I think I have to do this by hand. 7 is prime, right? So whoops, don't want to code. I'm color coding these so we can count them. Right? I want to make it easier to count. Are there any other prime numbers in my list?
I do know.
Is it 11? 11's prime, right? You know what I mean by prime, right?
Yeah.
Okay, right. And because like 4 is not prime because you can take 2 and divide it by 2, right? 6 is not prime because it's 2 times 3, right? And 8 is 2 times 2 times 2, right? But 7, you can only write it as 7 or 7 times 1 if you like, but there's no other way of breaking it down, right?
Yeah.
Okay, so the number of things in the event we're interested in are all these blue squares. Now we just count. So there's 3 there, there's 4 here, so that's 7. There's 6, 7, so that's 13, 14, 15, right? So the probability that x is prime is going to be equal to 15 over 36, because there's 36 total outcomes, right?
Mm-hmm.
Okay, so that's the answer we get, right? Here, let me unmerge this. Let me try to get this a little bit better. Okay, so let me, and then I'm going to come over here and just write that again as a formula. So the probability would be 15 over 36, right? And so the probability 0.4166, and I guess the sixes go on forever, right? So that's a good approximation. Okay. Now here's another way. Here's another way of doing the same thing. Okay, so I could instead actually compute the probability of getting a 2, a 3, a 4, a 5, a 6, a 7, etc. Right? So I could add that to my list. I could say probability that, in fact, let me write it like this. So I'll go write P of x equals x. Okay, and instead of calling this outcomes, I'm just going to call this x. Okay, so these are the outcomes I could get. I roll my 2 dice and I get an outcome, right? So I could get 2 1s and I get a 2, right? Or I could get a 3, a 4, 5, 6, 7, all the way through 12, right? So the little x here is all the different outcomes I could get, right?
Yeah.
Okay. And so the big X here, so this is sort of typical probability language. The big X is the random variable. That means I do the experiment and something happens, right? And so what's the probability that X equals something? I don't know why sorry, let me undo what I just did there. So now I just want to put these various things. So for X equals 2, right? What's the probability that X equals 2? Well, there is one way to get a 2 over 36 possible ways, right? So this will be equal to 2 over 36, right?
Okay.
Okay, and how many, sorry, 1, it'll be equal to 1 over 36. In fact, to make it better, let me just, the frequency is 1, so I'm going to use that cell, right? That way I can just copy things down instead of typing things out over and over, right? Okay, so that's my frequency. Okay, and in fact, I could even do better. Let me do this. No, I'll just keep it 36. Okay. If I want to go back and do this again and change the number of rolls my dice can have, then I'll have to modify this formula. So, okay, so I can just pull this down like that, right? And I get all these other probabilities, right? So there's all the probabilities. And if I could write them as percentages if we like, right? So like that. So I've got a 2.78% chance of rolling a 2. Right? When I roll my 2 dice, I've got a 16.67% chance of getting a 7, right? And a 2.78% chance of getting a 12, right? So you see how that works?
Yeah.
Okay. And we could even plot these things like, here are my possible outcomes and here are the probability. Whoops. Let me try that again. Here are my possible outcomes and here are my probabilities, right? And I could plot these. What's the best way to plot these? Let me plot these as, how could I plot these as like individual bars? Oh wait, I can't do that. I'm trying to think, how do I want to plot these? What's the best plot I have here? What will this do? Oh yeah, no. Okay, so, I see. Okay, no, okay, I got it. Okay, here, let me try it like this. So let me plot it like this. Okay, so I'm gonna plot it like that. There we go. Right. So there's actually a plot. Okay, now these numbers down here are wrong. So let me correct those. That's what I can do here. So I want these numbers instead. Okay, and then this is also like a histogram. This is an actual probability distribution, right? So the probability of rolling a 2 is 2.78%, and so that's like the top of that thing right there, right? And the probability of rolling a 3 is kind of close to 6%. The probability of rolling a 4 is kind of close to 8%, right? So this is also a distribution. This is a probability distribution. If I were to actually roll the dice a bunch of times, right, and then count how many 2s up through how many 12s I got, I would get something that would look sort of like this, right?
Yeah.
It's kind of a bell curve-y shape, right? I mean, It's more of just a pyramid, right? But kind of bell curve. I mean, it kind of goes up and down and it's symmetric and stuff like that, right?
Yeah.
Okay, so here would be an alternate way of doing the same thing we did a moment ago, where we literally counted the number of things in our event and the total number of outcomes and divided, right? So I could say, well, the probability that X is prime equals the probability that X equals 2, because that's a prime. Okay, in fact, let me do it like this. Or X, here's where we have to really use our knowledge of probability. X equals 3, or X equals 5, or X equals 7, or X equals 11, because those are all the primes, right?
Yeah.
Okay, and now we're going to use the fact that, so now you know, somewhere in the book you've learned some things about probability. So these ors are the same as, like, the book might write unions
Yeah.
of events, right? So if you have, you know, your event could be get a 2, right, which is right there. The other event here could be get a 3, right? But they're disjoint, right? There's no 3s that are also 2s, right? There's no 5s that are 3s or 2s, right? So these are all disjoint. And so when I have disjoint events like that, then this turns out I can just sum up the probabilities. So this is actually the same as P of X equals 2 plus P of X equals, whoops, 3 plus P of X equals 5 plus P of X equals 7 plus P of X equals 11, right? Those are all my possibilities. And so now I need to make this even longer again. Okay, no, even longer, ugh. Okay, even longer. Okay, let me combine those. Sorry, I'm probably spending too much time trying to make things look good, but okay, maybe I'm failing. Okay, go over there. There we go. Okay, so there's two very different looking computations, right? I'm computing P of X equals prime by counting, right, here. And here I'm computing P of X equals prime by, you know, kind of writing things out logically, right? There, that or statement, right? And then using my laws of probability, right, to change this into a sum of other probabilities, right? And then I can compute that. So then I can say equals, well, what's the probability that X equals 2, right? That one right there, well, it's this here, plus the probability that X equals 3, that's this one, plus the probability that X is over here, equals 5, plus the probability that X equals 7, plus the probability that X equals 11, right? And so I get that. And now let me turn this into a percentage so we can compare nicely, right? And these are exactly the same.
Yeah.
Right? Okay, so that's what I was trying to get at. There's two very different ways, right, of answering that question, P of X is prime. One involves counting and one involves using the laws of probability, right?
Yeah.
And it's that kind of thing that makes probability difficult, because very often when you attack a problem, you just don't know which thing to use, right? Do I want to try to count some stuff, or do I want to try to use some laws of probability to compute some stuff, or what do I want to do, right?
Yeah.
That's part of the problem. And the counting can sometimes get very tricky, as you may have noticed.
Yeah.
Right. So that's the thing. So if you have a particular question you want to look at, we can do that. Otherwise, maybe just think about.
No particular question.
Okay.
I was actually going over the major assignment for the writing portion. It's just like an essay, right?
Yeah, I mean, we give you a template that you should use lightly as a template. So it's got a bunch of questions, and each one of those questions should be addressed. At least if they're appropriate, they should be addressed, but they should be addressed in paragraph style, right? So you should take that template and kind of maybe leave the questions in there while you're writing your essay. But then make sure you answer the questions that apply.
Exactly.
What's in the material for the major assignment 3? It's called, I don't know, it's called writing template or something like that. I also gave it to you back in topic 3 DQ1, but it's in LoudCloud under the major assignment 3 stuff. It's in there.
Okay.
It's a doc. It's a doc file. So you can use that file, right? And it's got some headings which you might want to leave in place, or you might want to change them a little bit. There are things like, I mean, I think they maybe phrase as questions like, how will you manage your project, right? So you might take that and change it to management of project for the title of that section, or the header for that section, and leave those headers in just so I can look through and see those headers in there. All right. But then the main body will be a written paper. So
Yeah.
so essay like, yeah.
Okay. Okay.
Sound good?
Sounds good.
Okay. Cool. All right. Well, I had exactly one person come last week, and so far you're the only person this week. So we'll see. I don't know why. I used to have lots of people come to office hours, but they're getting to be less used.
It's because they're understanding more. The
Yeah, maybe.
videos are helping a lot.
Yeah, hopefully good. Yeah, who knows? Maybe I guess if you don't have any objections, if I look at this later and think that what we just did is worth posting somewhere, would that be
No,
okay with you?
it's very helpful, and it might help another student.
Yeah, I mean that's how I get a lot of the videos, is just using these sessions to make videos. So